As an introduction to our linear functions unit, we're going to deal with a scenario at Crazy Cakes Bakery. At Crazy Cakes Bakery, they're awesome at making cakes, but they're not very good at math, so they're going to need your help. So congrats on your new job at Crazy Cakes Bakery. The one thing you need to learn from very upfront about their recipe is that it takes 1 bag of cake mix and 1 cup of water. It must be very precise, so it's important that we go through some practices and make sure we know how many cups of water and how many bags of cake mix are going to go for each cake. So sometimes they make small cakes just for small parties or get-togethers, but sometimes they make big cakes. So we're going to have to figure out how to scale up and down our recipe to ensure that we're making the cake as perfect as possible with the right amount of ingredients. So for our first job, we're going to be creating a cake for Sally's birthday party. She's only having a few friends over, so she's only going to need 1 bag of cake mix for her cake. So how many cups of water do you think that we're going to need? One. We're only going to need 1 cup of water because we used 1 bag of cake mix. This is what the recipe tells us to do. So we know for our first job for Sally's cake, we're going to put in 1 bag of cake mix and 1 cup of water. Voila. For our second job, we're going to make a cake that's just a little bit bigger. This time, we need to provide a cake that it feeds an entire class for their end of the year celebration. So for this cake, we're going to use 4 bags of cake mix. So how many cups of water do you think that we're going to need for this cake? 4. We're going to need 4 cups of water because we used 4 bags of cake mix. So let's think. Let's take a moment to compare our 2 jobs so far and see if we can try to think about what kind of rules or what kind of patterns we're noticing. So for our first job, the cake we used had 1 bag of cake mix with 1 cup of water. While in the second job, we made a cake that had 4 bags of cake mix with 4 cups of water. So there's a lot of words here, and so let's try to figure out a way to just make it concise so we can just be dealing with the numbers, right? Because we're really concerned about how much to put in each cake. So let's create a table. So in one column, we're going to have our bags of cake mix, and in the other, we're going to have our cups of water. So with 1 bag of cake mix, it's going to correspond to 1 cup of water. And similarly, 4 bags of cake mix are going to correspond to 4 cups of water. So here we have our chart again, and this is a great way to display it, but we also have another way of displaying these points. 1, 1. That's going to correspond to 1 bag of cake mix and 1 cup of water. So this is going to be the coordinate pair that we're going to use for the future to represent how many bags of cake mix versus how many cups of water. So if we were to represent 4 bags of cake mix and 4 cups of water, we would say 4, 4 to represent this coordinate pair. So for this next scenario, we're going to have to make another cake. But this cake is going to have 2 bags of cake mix. So how much water are you going to get to put in this, based upon the patterns that we're seeing here? 2. Since we had 2 bags of cake mix, we're going to have 2 cups of water. And the coordinate pair for this? 2, 2. That's going to be the coordinate pair that corresponds to the amount of cake mix and cups of water we need for this particular cake. Oh no. For this next job, one of the workers forgot to tell us how much cake mix to put in. But we know that they already added 7 cups of water for our recipe. So how many bags of cake mix are we going to need? So now instead of dealing with how many bags of cake mix we know we need, we're dealing with how many cups of water we have. And we have to make our bags of cake, or we have to put in the proper amount of cake mix compared to this. So for 7 cups of water, how many bags of cake mix? 7, right? So since we put in 7 cups of water, we're going to need 7 bags of cake mix to even out this recipe and make it perfection. This is represented as 7, 7 as a coordinate pair. So now that we have our coordinate pairs, these are corresponding to bags of cake mix versus cups of water, but if we were to put this on a graph, we'd be able to put this as a x and a y coordinate. So let's do this now. So for our Crazy Cakes Bakery, we're going to plot our points. Our 1, 1 by going over 1, 2 bags of cake mix and up to 1 cups of water. And we can do the same for 4 bags of cake mix and 4 cups of water. And then so on to 2, 2, and 7, 7 on our graph here. So as we can see, not only does this sound like we have a pattern whenever we are talking about it and comparing all these recipes, but it also looks like it whenever we put it in a table, and similarly as we put it in a graph. It looks like there's some kind of trend. So let's add a trend line, or just a line that we think is going to best fit this data. And looky there, we have a line that goes through each point exactly through the middle. So as we can tell, this line that we created here goes through the points 1, 1, 2, 2, 4, 4, and 7, 7 perfectly. And it's a straight line. So this is where our linear function terminology is going to come from. So as you think about it, feel free to rewind and look back through these things and write down some observations that you're making about this recipe that we have. So the first observation is that our line goes through the origin. So this line is going to pass through the point 0, 0, because if we had 0 bags of cake mix, we're going to need 0 cups of water because we're not making a cake. Another observation could be that the y-coordinate is the same as the x-coordinate. Each time we know that if we know an x-coordinate, we know the y-coordinate corresponds because they're the same. And similar with it, if we know the y-coordinate, we're going to know the x-coordinate. So to model this with an equation that passes through all these points, we can say y is equal to x. What? Now Crazy Cakes Bakery is making brownies too? No way. Now we're going to have to try to figure out a recipe for our brownies. So we're thinking that 1 bag of brownie mix is going to go with 2 eggs. So this is going to be the new recipe that we're going to need whenever we're making brownies. So let's first just test this recipe and do a little practice before we premiere this out to everyone. So we're just going to make 1 batch because we just want to try it out, and we're going to use 1 bag of brownie mix. So how many eggs are we going to need based upon our recipe? 2, right? Because with each bag of brownie mix, we're going to need 2 eggs. Now that we feel like our brownie mix it's pretty excellent, we're ready to reveal it, let's make a big cake to show off to everyone. So we're going to need 3 bags of brownie mix for this big tiered cake. So how many eggs are we going to need based upon putting 3 bags of brownie mix in? 6. We're going to need 6 eggs corresponding to our 3 bags of brownie mix. So let's take a moment to think about this again and just kind of talk through, reason through, write down any observations that you might be having. So for our first try, the brownies we made used 1 bag of brownie mix with 2 eggs. And for our public event, the brownies we made used 3 bags of brownie mix with 6 eggs. We know that another way that we can represent this is with a chart. So in the first column we have our bags of brownie mix, and in the second column we have eggs. So our 1 bag of brownie mix corresponds to 2 eggs, and our 3 bags of brownie mix corresponds to 6 eggs. Again, as we did before, we want to be able to represent these in multiple ways, so let's try to put these in coordinate pairs. So if we know that 1 bag of brownie mix goes with 2 eggs, how can we represent this in coordinate pairs? 1, 2, perfect, because it's our x is going to be our bags of brownie mix, and our y is going to be the number of eggs that we need. So for our first pair, it's going to be 1, 2, and for our second, is going to be 3, 6, corresponding to 3 bags of brownie mix with 6 eggs. Now that we're getting good at this, let's try another scenario. So we're going to make brownies with 2 bags of mix. So how many eggs are we going to need? 4, right? Since we had 2 bags of brownie mix and we need 2 eggs per bag, we're going to have 4 eggs. And representing this in coordinate pairs, 2, 4. Oh no, not again. That silly worker forgot to tell us how much brownie mix to put in. But we know that they cracked 10 eggs and put in the recipe. So how many bags of brownie mix are we going to need? So now we're dealing with the amount of eggs that we have, and we have to figure out how many bags of brownie mix. So based upon the trends that we're seeing here and the recipe that we know, how many bags of brownie mix are we going to need? 5, because we only need 2 eggs per bag of brownie mix. So if we have 10 eggs, we're going to need 5 bags of brownie mix, which can be represented as the coordinate pair 5, 10. Let's represent these on a graph and see how they might differ or be the same as our graph from the first recipe we had. So now that we have our new chart here corresponding to our values, and we can see that whenever you go to 1 bag of brownie mix, you have to go up to 2 eggs. And then with 3 bags of brownie mix, we have 6 eggs, similar with coordinate points 2, 4, and 5, 10. So these are going to be the coordinate points and the coordinate pairs that we figured out, and now we're just plotting on our graph. So let's take a deeper look at the function that goes through all these. Once again, it's a straight line. So this is another linear function because whenever we create a line that passes through each of the points, it goes through straight. So now we have our line that goes through 1, 2, 2, 4, 3, 6, and 5, 10. Now that we've gone through this recipe and we've been able to look at it in a chart, in a table, in a graph, just talking through it, just knowing the recipe as a whole, which are our instructions, what observations can you make? Pause the video or go back through to create some. So the first observation is that our line goes through the origin again, right? Because if we have 0 bags of brownie mix, we're not going to need any eggs because we're not making any brownies. Similarly, if we don't crack any eggs, then we're not going to be able to put brownie mix in because we can't make brownies without them. The other observation is that the y-coordinate is double that of the x-coordinate. So each time we have our x-coordinate, we have to double it to know how many eggs we get. So how do you think we can model this as an equation that passes through all these points? Y equals 2x, because for every x-coordinate that we have or every brownie mix we have, we're going to need double that in the amount of eggs, which is our y. So now that we've gone through and just had a small introduction to linear functions, bring your notes to class tomorrow and so that we can talk about what you learned from this, and we're going to have a brief discussion about our Crazy Cakes Bakery.